So last time we did set up this very basic loop that acquires the swap chain image, submits an empty batch of work, and returns the image for presenting, along with some tricky synchronization system for this. Now, from here, there are at least 3 different paths to take. First, we need to handle the swap chain recreation. For example, when the window is resized or minimized, we need to take care of that. Then we ideally need to avoid this waiting, at least for one frame, and introduce multiple frames in flight so we can prepare the next frame's work on the CPU while the GPU is drawing the current frame. And obviously we also need to do some progress towards actual rendering. So all of this is important, but I've decided that all the fixes and optimizations can wait a bit. Let's actually do some work to get us closer to changing pixel colors on the screen, right? So remember last time we mentioned that it's the qSubmit call that submits the actual work to the GPU. And this submit info structure has these command buffers fields that you can pass batches of commands through. This means that we need to create command buffers in the first place, right? So command buffers are things that need some clever memory management, because we can have multiple buffers and we're gonna be recording different amounts of different commands into them, so it's not known exactly how much memory do we need in advance. And also it would be nice to reuse memory for the commands, right? But thankfully we don't really need to think about this too much, because the driver will take care of it. And we just need to create a command pool object with some hints about the intended usage, and then we can allocate command buffers from that pool. So let's do that. Let's keep it all in our main function for now. Let's introduce a variable for that of type vk command pool. Follow the usual pattern of create commands. So vk create command pool, that takes a device, the create info, the allocators, and the pointer to result. Now the create info is obviously command pool create info with a fitting s type. Here we need to specify the qFamily index, because you create a command pool for submitting commands to a specific queue. And the spec explicitly says that all the command buffers allocated from this command pool must be submitted on the queues from the same queue family. So that's why we need to specify it here. Thankfully we have it stored, gq command family index. And now there are some flags. And if you open the documentation here, it says that transient specifies that buffers allocated from the pool will be short-lived, meaning that they will be reset or freed in a relatively short time, right? And this is a hint for memory control, and this is what we are going to use, because our command buffers will be indeed quite short-lived. We will just fill one for a frame with some draw commands and whatnot, and then just reset. Next, this reset command buffer bit allows to reset an individual command buffer from this command pool. And this is something that we could do, but actually it is recommended to reset the whole pool, because it's faster, it's more performant when it comes to memory management. So it's just easier for the driver. And that's fine for us, so we will not supply this flag. And the protected, that has to do with some protected memory and stuff for DRMs. This is something that we don't care about at all for now. So this should be it. Let's also defer the destroy. So that is very similar to other destroy functions. It takes device, the object, and the allocators. Nothing new. Now from this command pool, we can allocate a command buffer. For now, let's just have one command buffer and allocate it with this allocate buffers procedure. That takes the device, that takes the allocate information. I will use this AI abbreviation that of course has nothing to do with any kind of AI, it's just allocate info, similarly to the create info for CI that I use here. And this call can allocate multiple command buffers, so we pass a pointer to an array. But since we are gonna be allocating just one, I'll have a single variable of command buffer and pass a pointer to it here. And here I named it just CMD, because it's actually quite nice to have a short variable name, because you're gonna be repeating it a lot when recording commands. Wrap the function with vkcheck, and now let's provide the allocate info. Again, it's a standard structure, command buffer allocate info with a fitting s type. Here we specify the command pool from which to allocate a buffer. That's our command pool, of course. Next we specify the level, And there are primary and secondary command buffers. So the primary command buffers are the ones that you record commands onto and then you submit them directly to the GPU. The secondary command buffers is something that you can also obviously record commands into, but you don't submit them directly, but rather you record their commands as part of a primary command buffer. And this is an interesting thing to explore later, because that would allow you, for example, to pre-record some commands, or you could also do multi-threaded command recording, and then you just collect all the secondary command buffers for some complex scene and combine them all into a primary command buffer. But of course, for now, we are not gonna be doing this, so we are selecting the primary command buffer. Next, we simply specify the number of command buffers, and we just want one command buffer for now. And we can also free the command buffers, but we don't really need it in this case because this will be our only command buffer for now, and the destroy command pool will actually free all the associated command buffers anyway. So that should be enough for creating the command buffer. Now let's go to our main loop, and just before submitting we want to record a command buffer. And how we do this? Well, first we need to call this begin command buffer procedure that takes a command buffer that we want to, well, begin recording to, and then a begin info argument structure. So the type is command buffer begin info, the S type is fitting, and that takes some flags. And those are again hints about how we use the command buffer, and the interesting one is this one-time submit. So looking at a spec that specifies that each recording of the command buffer will be only submitted once, and the command buffer will be reset and recorded again, which is exactly what we intend to do with per frame command recording. Then there's this render pass continue bit that we can completely ignore for now, because it's actually only for the secondary command buffer, so we are not covering this for now. And the simultaneous use bit is about submitting it to multiple queues at once, which we are not doing as well. So we will ignore that, but we will specify this one-time submit bit. And the SP inheritance info is also something that is only needed for the secondary command buffer. So this is something that we will ignore. Now, after the begin command buffer, we can record some commands. Let's leave a placeholder comments for now here. But after recording the commands and before submitting the whole batch to the GPU, we need to end the command buffer. And predictably, this is done using the end command buffer call that simply takes a command buffer. Very simple. So now we need to specify this command buffer in our submit info, so it's actually submitted. And this is what this command buffer count and p command buffer fields for. So let's specify that we are submitting just one command buffer. And for p command buffers, let's also just specify a pointer to the first and only command buffer that we have. Now this is almost good. One thing that we still need to care about is resetting the command buffer. Remember that here in the command pool CI, we did not specify this reset command buffer because it's actually recommended to reset the whole command pool, right? So we cannot reset individual command buffers. If we would specify that, then the begin command buffer would actually implicitly reset the buffer for us. But since we are not doing that, we need to reset the whole command pool. Thankfully, this is very simple. We just use this reset command pool procedure. That takes a device, a command pool, and then there are these flags, and the only flag that we can specify is release resources, which basically will release all the resources that the pool currently holds back to the system, instead of keeping it for potential reuse. We want the reuse, so we will not specify this release flag, just like this. Now the command buffer is yet another resource that should be carefully synchronized between different frames, right? So let's quickly analyze how we use it. So for each frame, we are waiting for the fence that will guarantee that the previous frame rendering is fully done, right? And we can reuse all the resources, including the command buffer. So we fill the command buffer with some work, then we submit it, and when all the work is done, the fence will be signaled, and by that time, the command buffer will be free to reset and fill again, right? So this should be fine. Now, how do we record commands for the GPU? We do this with this family of functions that are prefixed with CMD. And as you can see, the first one that I got in my completion is exactly CMD draw. And this is where you would specify a command buffer and the count of vertices and instances to actually issue an actual draw call. Obviously, we can't really do it yet because we don't have any render target attached, and this is something that will require some more setup. But you can see that there is a whole lot of different commands that you can record, and this is where we will start actually doing some work for drawing. So there's this interesting command called cmd begin rendering. This is what we're gonna use for actual rendering. Normally in Vulkan 1.1 and in a lot of tutorials from that time, you would need to set up something called render passes and frame buffers and stuff like this to be able to render into images. But this CMD begin and also end rendering, it's much simpler. We don't need to do any of that, and it's a bit more straightforward, and we'll use that instead. This was originally provided as an extension called dynamic rendering, but nowadays it's part of the core Vulkan API with Vulkan 1.3. So this is what we're gonna do in the next video, so stay tuned for that.